This is chapter number 4. We put the first concept, scatter diagram. Scatter
Yeah.
diagram is a concept which is coming from O level IGCSE. And what is the introduction? A scatter diagram shows the points as crosses on a graph related to different coordinates. Normally, when in a statistical survey, you are making data about different variables, you will identify that some variables are mutually connected. For example, when petrol prices increases, food prices also increases. When international fuel prices increases, the fuel prices in a country also increases. When governments decrease the interest rate, the the
Yeah.
the progress of economy increases. So actually, there are some quantities which are mutually related. I'll take the example of physics now. For example, when you change the pressure of a gas, volume of the gas also changes. The difference in the statistics and in physics is that physics follow only the established relations like Boyle's law, like Charles' law, like Newton's second law. But statistics accept all possible interactions. Maybe they are not related, still statistics would be ready to accept it. For example,
Yeah.
number of restaurants in a town and the scale of income in that town, they are partially related. They are partially related. Nowadays, a big
Mm.
discussion going on about the electric vehicles. Electric vehicles are there to replace the fuel vehicles. So now there is a discussion that people are taking survey that how much fuel vehicles are being purchased and how many electric vehicles are being purchased, even though they are not related to each other directly, but they are in a competition. So my first concept, what is a scatter diagram? Scatter diagram is a diagram which shows two variables under investigation. They may be related, they may not be related, they may be partially related. For example,
Yeah.
number of crimes in a town, number of crimes in a town and number of barber shops in the town have no relation. Still, they can be put on a scatter diagram. So this is the first concept. So you give the heading scatter diagram,
Yeah.
and then you have
Yeah.
to the first concept in your memory. And the main thing in statistics, the statistics do ask theory questions. That is the difference between pure maths and statistics. So it's not only a formula. So can you repeat, looking at the screen, what is a scatter diagram?
Sir, so like as we know, it's not like normal. It's a diagram that
It's a
has points, but it's like crosses instead of points that shows the coordinates, and the it represents two variables, and they have like if one variable changes, the other variable will also change. It's like
this is
that.
important. This is important to understand that these two variables may or may not be related.
Okay.
Okay. For example, the health budget and number of patients are
Yeah.
partially related, right? Health
Yeah. Yes.
budget, health budget and number of patients are partially related. Okay.
Yeah.
But for example, number of cars and number of A grades in a town,
Yeah, they're not related.
they are not related, but they can also come here. Scatter
They
diagram, scatter diagram is there to show two variables which may be related, may be partially related, and may be not related at all.
Yeah.
Okay, now this is the basic concept. So this is the concept. And for example, here, income and year number, they are just like two data sources. Now, in a scatter diagram, do not join the points. I mean, do not
Yeah.
make a zigzag, otherwise it will become a polygon.
Yes.
Do you
Yes, sir.
remember polygon?
Yeah. Yes, sir. Frequency polygon.
Yes. So you're not supposed to join the points. Now we are introducing our next concept. We introduce a term in this chapter which is called bivariate data, are the data which pairs of values for two variables. Again, they may be related, they may be not related. Number of A's in a school and number of teachers in a school are partially related, but not a direct
Okay.
relation. So this is called a bivariate data. Bivariate data can be represented on a scatter diagram. So now you have to, after giving the heading, you have to copy this.
Okay, sir. Yes, I wrote this point.
Okay. Line of best fit. This concept is coming from OIGCSE Physics, paper 6. A line of
Yeah.
best fit is a straight line that minimizes the distance between it and some data. This is a different definition as it was in our IGCSE, but the concept is similar. This is
Yeah.
called a best fit line. You can identify here that best fit line is passing through all in between the crosses. It is just like a line which is representing the population of the crosses. We used to draw best fit line in ATP paper in which they first used to point the plots and then they asked to draw the line of best fit. Line of best fit is actually there to show a relationship in a scatter plot. Maybe the line is going upward, just like here, if it's a, look at here, mark in general knowledge test, and here IQ
Mhm.
level. So as the IQ level is increasing, mark in general knowledge test is also increasing.
Okay. Yeah. Yes, sir.
This best fit line shows that as IQ level is increasing, marks in general knowledge test also increases.
Increase. Yeah.
Even though they're not related, again, it's not a rule that someone has an high
Yeah.
IQ can be good in general knowledge. But again, that statistics say virtually you can compare anything. You can
Yeah.
compare
Exactly. Yeah.
anything which may be relevant, which may be irrelevant. So it is like a line which shows the relation between or the trend between the two variables. Okay. Now give the heading line of best fit.
Yeah. Yes, sir. I gave it. Yeah, I wrote this down, sir.
It's your choice if you want to copy that, but notes will be, we can share the notes digitally. Our statistics here, this chapter needs a very good understanding of the content because this topic was not
Yeah.
there at all in IGCSE. This is a brand new topic. Probability and data representation were partially in IGCSE also. But
Yes,
this is
sir.
a total
Yeah.
different chapter, not a difficult chapter, simple, straightforward formula learning, but the theory is very important, especially it is related with the theme of statistics. What is the theme of statistics? Statistics say that it's a language of data for every
Mhm.
situation, like the growth rate, the student GPA, the grade boundaries, the threshold, and the marks allocation system, the poverty rate, the growth rate, the death rate, and also multiple values. So statistics has a theme. The theme is there that every data has a language, it has a narration for the situation. Companies progress, companies make loss, profit. So how they represent it, they draw these type of scatter diagrams and then they draw the line of best fit. Why? Because unlike physics or chemistry, the points are not always in a pattern. In real data, fluctuation is there. Actually, in real physics also, a lot of fluctuation occur, but not that much as appear on a scatter diagram. So this is the theme of the statistics. Now, the line of best fit is used to express a relation in a scatter plot. This relation is called correlation. Now you have to give the heading correlation.
Correlation. Okay.
This word has a very interesting relation with the word relation.
Yeah.
This word has a very interesting relation with the word relation. Relation means two quantities are having some interdependent connection. Like, for example, Ohm's law say that voltage is directly proportional to current. This is a relation. This relation has some physical facts. It's a correlation. What is a correlation? A mutual relationship or connection between two or more variables. As I gave you the example, unforgettable example, Ohm's law. Voltage is
Yeah.
correlated with current. So
Yes.
it's a mutual relationship. If you find a solid relation between two quantities, you call it correlation. Number of immigrants and the economical parameters in a society, they are partially related. So maybe you find a correlation, maybe you do not find a correlation. Now look at this. There are three types of correlation. Achha, first you give the heading correlation.
Yeah, I give that, sir.
Achha, now can you give me the concept back looking on the screen? What is correlation?
Like, I mean, it's from the definition itself, like, uh, a relationship between two variables, like it could be like mutually, as you
Anything?
talked about Ohm's law. There's like a
Hmm.
similar, like, what's it called, like a connective relationship between like the variables, like as you talked about the voltage and current being there, and then other
Good.
things,
Now,
like a similar
now
relationship between stuff.
can you think of any other example in physics or chemistry where you used to have a proper relationship? Like I gave you Ohm's law.
For correlation.
Correlation you can say, but any concept in physics, a lot of concepts are there in physics which are all relations.
Like we can talk about what's it called, power, work and power, and or work and time, like together, or
No, those
force
are formulas talking about relation like directly proportional, like inversely proportional.
yeah, we can talk about the Boyle's law, like a pressure and
Boyle's law,
temperature.
ठीक है. But then, Boyle's law, I told you, na, think about something your
Okay,
memory.
okay. uh
In physics, any relation.
like there's also about like the frequency and the time period, like frequency is
Yeah.
inversely proportional to the
Frequency
time
and time
period.
period are inversely proportional. That's a good example. Now, this
Yeah.
example gives you the idea. Then what is the difference between this concept and the concept in stats? Why we never use the word correlation there? Again, that physics concepts are considered as established facts. There are no
Yeah.
fluctuation outside the limits. Slight fluctuation occur. Here, statistics doesn't work like that. Statistics work on survey.
Yeah.
So when you make a survey, data can always fluctuate. Now, there are three types of, right under it, there are three types of correlation. After
Yeah.
giving heading, right under it, there are three types of correlation.
Yes, sir, I wrote it.
There are three types of correlation. Number one, positive correlation. This is called
Yeah.
a positive correlation. Look at this. when two quantities increase and decrease together, again, this is not directly proportional. They are going together, that's all. So now give the heading number 1, positive correlation.
Yeah, positive correlation.
Now you have to copy this.
Okay, sir. Yes, sir, done.
So what we are showing,
Yes, like a positive correlation, like they're like there's like
one
a if
quantity
it's
is
a casual
increasing.
relationship, one is increasing and then the other will increase, and then if one decreases, the other will also decrease.
Yes. So one quantity is increasing and the other quantity also increases. The two quantities increase and decrease together.
Yeah. Yes, sir.
The two quantities increase and decrease together. Number 2, negative correlation.
Yeah. Negative correlation.
So give the heading.
Negative correlation. Yeah.
Now, negative correlation is a case when one quantity increases and the other quantity decreases. Look at this.
Hmm. Yes, sir, exactly. Okay. Hmm. Yeah. Okay. And then if the other will decrease, the other quantity will increase. It's gonna be like that.
One quantity increases and the other quantity one quantity increases and other quantity decreases. Now look at this. Again, the same rule that the gradient is found by using a triangle. Number 3, no correlation.
No correlation. Yeah. Yes. Yes, sir.
So here the two quantities have no relation like this. It cannot be either going upward or going downward.
Yeah. Yes,
Now
sir. Okay.
copy this.
Yeah, sir. I'm copying it.
This is called no correlation.
Yes, sir. I copied it.
Positive correlation, negative correlation, these are the things. Then correlation describes the nature of the linear relation between independent, they call it explanatory variable in our course. Second, dependent, which they call response variable in our course. They say whatever comes on the x-axis is the independent variable. What is an independent variable? It is the variable which we are changing. It is the variable which we are changing. Then what is dependent variable? It is the variable which is changing due to our variable. So independent variable has another name in this chapter. The name is explanatory variable. And the dependent variable has another name called response variable. So you have to copy this now. These
Okay.
terms you have to memorize.
Mm-hmm. Yes, sir. Yes, sir. Done.
Okay. Now, these are the variables. Now, extent of correlation, there are possibilities that if the points or the crosses are close, it is said to be a strong correlation. Like in this diagram, look at from left to right, the first diagram, the crosses or dots are very close to the best fit.
Yeah,
It's a
strong.
strong correlation. But if you
Yeah.
come down in the second line, you can see the dots are scattered. It shows weak correlation. It shows weak correlation.
Yeah.
So this is called extent of correlation. So what is extent of correlation? If the crosses or the points are well, well scattered across the best fit, they are far away, it's a weak correlation. If the points are close, they are not far away, it's called as strong correlation. So when the dots are close, do you call them, you have like, this is an
A strong
example.
correlation. Yeah.
This is called
Negative.
strong correlation. Now,
Yes.
note that a correlation between two data does not necessarily mean that one caused the other. It's a very important concept which I explained in the start. There may be you are connecting those variables which are physically not connected. Number of shops, restaurant shops in a town, and number of crimes in the town has no relation, but you can put them here because statistics is blind in that sense, not like physics, where you go in the lab and you test are they really related or not. Like Charles' law says, volume is proportional to temperature. So you increase the temperature and you see the volume changes. Here we have nothing like that. So here we can sometimes connect irrelevant facts. Now you have to copy this syllabus concept.
Augustine. Yes, sir. I copied it.
Equation of a linear regression. Linear means equation with variable power 1.
Okay. Yeah. Yes, sir. Equation of.
Give the heading equation of a linear regression.
Yes, sir. I gave it.
Now look at this. This is a straight line. This is the line of best fit. This is called linear regression line because it's a straight line. This is a straight line. This is called linear regression line. So when a scatter diagram shows a correlation, we can draw a line of best fit. Here we have shown the crosses and a line of best fit. Now, this is the regression line, which we call y on x. It is written in the form a plus bx. A plus bx is a modified form of y is equal to mx plus c. And the letters are changed, but actually it is the same equation. It is coming from y is equal to mx plus c. Only the syllabus wants to make some touching effect. So they just want to make a new equation. Otherwise, it's y is equal to mx plus c. Remember,
Hmm.
is the gradient and what is A? A is the y-intercept. Originally it is what? Originally it is y is equal to mx plus c. It is originally y is equal to mx plus,
MX plus C.
yes, it is basically a form coming from there. So now you have to observe that this is a line of best fit. The regression line y on x is written in this form. So now you have to copy these two lines in the last. The diagram is your
Okay.
choice. If you want, you can draw it. This is a pattern, but what he's showing by the dotted lines that the best fit is actually going in between, and the dotted line is showing the separation of a cross or dot from the best fit.
Hmm. Yes, sir. I got it. Yeah, I'll just like make a rough sketch.
Okay.
Yes, sir. I copied it.
If we know the value of the independent variable from a bivariate data, the best fit lines actually can be used to read any missing value. Now, regression line is basically a line of best fit. Regression line is a line of best fit. It can be drawn by different methods, and we will follow only one method. We actually have two types of regression line. One is called y on x, and the second is called x on y. Normally we work out with the first one, y on x, which is originally y is equal to mx plus c. So we put our next line.
Yeah.
Linear regression line. It has two types, y on x, and the second is x on y. So you have to copy this.
Okay, sir. Just a second. Yes, sir. Copied it.
Now, number of Save My Exam question packs completed. This is a dot and cross. This is a cross diagram from the website Save My Exam. They are showing the percentage scored on A-level statistics exam and number of Save My Exam question packs completed. This is a very interesting diagram. When I saw it, I thought I should use it. They want to
Hmm.
publicize their website and they are collecting the data from the student. They claim that they have collected the real data. They ask the students how many past paper booklets you have completed from our website and then what you got in A-level exam. Right now, they are talking about statistics. The data is looking to be a bit scattered. This scatteredness is the theme of statistics. Unlike physics, chemistry, this theme is not a pure linking line. It's always a scatteredness. Now, the question says the equation of the. Achha, let me share the question first. Let me share the question, the example on the chat. So I have to post the homework also from the PDF. Um, is the PDF pinned? The PDF of topical paper, is it pinned there? PDF, the P1, the pure P1 PDF which I had shared with you. Is it pinned on it?
Which one, sir?
Uh, the PDF which we were discussing
Yeah.
in the start, the questions PDF, the topical question. Is it
Yeah. Yes.
is it there pinned or it's not pinned? Acha,
Yeah,
look
yeah.
at
It's pinned in the chat. Yeah.
it is pinned.
Yeah.
Acha, that's good to know. Just put a homework from there. Acha, I have shared the question. You can refer in your notes. Example, and as a patron, you can say a reference number.
Hmm.
That will be a reference that what you are solving. So, okay, do one thing. Now give a side heading example and write under it reference number 1.
Okay.
As I used to do this also with O-level also, that obviously copying this question will take unnecessary time. So look, I'm
Yeah.
writing here reference number 1. Okay, the same you should put there in your register. Draw the
Okay.
regression line onto the scatter diagram. If you have any tablet or you can draw it on the screen, that would be ideal.
Hmm. Okay, sir. Wait, I'll try.
Yes.
Okay. So do you have any access to any tablet or something? So
Yeah,
you have
sir,
to.
that's what I'm doing. Like, yeah, I'm using it, sir. I'm just making the line.
Okay, that's very good.
Okay, sir, I made my line. Like a best fit line, basically, right? So,
Yes.
I'll just send. I think my line is like similar. Yeah.
It should be similar. Obviously, save my exam. These people must have done it by any machine. So by any computer, something, but it should be look like that.
Yeah.
Okay, now he
Let me
says
compare. Yeah.
interpret the meaning of the values 18 and 1.3 in the diagram. So you will remember that 1.3 is the gradient and 18 is the
Yeah.
y-intercept. Okay, so what is part 2? 18 is the, you will tell the examiner that look, 18 is the y-intercept and 1.3 is the.
Gradient. Wait.
Yes.
Yeah.
1.3 is the gradient and what is
Gradient.
18?
Y-intercept.
Acha, now give a physical translation to your concept. What is y-intercept? Y-intercept is the place where,
Where the line is intercepting from. Like, yeah,
but
like,
theoretically y-intercept means where x becomes 0.
yeah. When x becomes 0 and the line is intercepting at y.
Huh. So now you have to translate this. You have to look at the sketch and you can see that what is 1.3 and what is 18 on the graph. There you will understand a very important concept and you will need your knowledge of O-level maths graphical solution. Now, look, is it cutting here somewhere around 31?
Yeah.
Achha, now look here. Do you remember how we used to draw a line on a best fit line is always drawn by imagination, okay? But how we used to draw equation of a straight line on a graph?
Yeah, sir. How do I draw a straight line?
Like 18 plus 1.3x is a line. So how we used
Yeah.
to draw it on,
Like we used to find some coordinates, like give like a value to x and y to find, and then we used to get coordinates and then
hmm,
plot them together. Like x equals to 0, and then we get the value of y, something like that. Or we give like a value of x as 2, and then we get the value of y, and then yeah.
okay, now you have to look at this and I will follow the things you have told me that this is the method I used to follow. Acha, now we make a concept. When the line or when the regression line equation is given, we will make a table of 3 to 4 points and we plot it. But we have to carefully see what points are available. Like I can see that 31 is on the x, y, 31 is on the, 31 is the intercept.
Yeah,
31
30.
is
uh,
the, huh, y-intercept. 31 is the y-intercept. 31 is the y-intercept. 31 is the intercept. 31 is the intercept. 31 is the y-intercept. 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 31
Yes, sir.
And we can plot any points. It's a gradient. Gradient is 1.3. So if I put x as 30 in the equation, if I put, can you do this calculation? X is equal to any number.
Yeah.
Let me take 20.
Okay, x equals to 20. So wait, 18 plus 103 times 20. 44. Y equals to 44, yeah.
Okay. Then take one more point, which is fitting on the table also. Let's say 40. Can you tell me what are you getting by putting 40 on the in the equation?
40, I'm getting 70, sir.
40, you are getting 70. And one more, let's say 60.
60. Okay. It's 96, sir.
To plot 96. Now, plot these lines on the graph I have shared with you.
Okay, sir. Yes, sir. When I'm plotting them, it's coming exactly on the line, like, I drew.
So now here you will understand that our best fit quality is there. Then what is the
Yeah.
rule to understand? If a line, if an equation of regression line is given, we won't plot it by our eye vision. We have to plot it by the table.
Yeah. The
Okay.
table. Okay.
Now we
Yeah,
have
then it's
to,
going to be more accurate. Yeah.
you have to identify another important thing, that the x-axis is not starting from 0.
Yeah, it's not. The
So
jagged
you
line.
have to take a care of it because it won't give you the intercept directly. X-axis is not starting from 0. Then what is the trick? Look at this trick. Can you see 31 here?
Yeah. Yes, sir. I do.
How
Hmm.
we are getting 31? I have I changed the color also to highlight.
Because we chose the value of x as 10 here.
Hmm. But apparently 31 is the y-intercept,
Hmm.
but
Yeah, it
it
is.
is, but in reality, it is not the y-intercept.
Yeah, it is not because it's supposed to be 18 according to our formula.
But why it
Like,
is not the, because it is 10. So you will tell the examiner here that 31 is not the y intercept. So you have to copy this part 1 working.
Okay, so just a minute. Yes, sir, I copied it.
Now, this is the coordinate system. Now, part 2. Interpret the meaning of the values 18 and 1.3. 18 is the y-intercept and 1.3 is the gradient. Y-intercept means where x becomes 0. What is x? X is the number of Save My Exam questions. So when you say 18, it means there is a student who didn't practice anything from Save My Exam and he got a percentage of 18.
Yeah. Okay.
Can you
18.
understand what I'm saying?
I'm getting like a bit of idea.
Intercept means x coordinate, x should be 0. So in reality, the intercept would mean that the person who has not done any Save My Exam workbook and still he got how much? 18%.
Hmm.
What's the meaning of 1.3? What's gradient? Remember, gradient is y upon x.
Yeah. Yeah, yes,
Gradient
sir, it
is
is.
y upon x. Acha, what is on the y-axis? The percentage obtained in the exam. And what is on the x-axis?
The x-axis is the number of question packs.
Yes, so it means gradient shows the ratio.
Yeah.
Percentage obtained per unit exam packs. So look, what is the part 2 answer?
18 is the expected score of no packs. Okay. And then 1.3 is the increase. Okay, yeah. Okay, they're using the what's that called?
They are
Y and
using the
x-axis here.
concept of gradient. They are using the
Mm-hmm.
concept of gradient. That gradient is actually the ratio of y to x.
Yeah.
Intercept, intercept means where the x value becomes 0.
Yeah. Yes, sir.
Okay, so you have to copy this answer.
Yes, sir. I'm almost done. Yes, sir. I copied it.
Now see the third part, why the regression line given should not be used to estimate the percentage when someone has completed 80 question packs.
80 question packs. Okay. Oh, because I mean, like with the range for us, we have still 60. So
The scattered
80
data, the scattered data covers till
till 60. So it's outside of the range.
why? Because it's outside the range. And
Yeah.
so, and you know, in O level, we can also extend a graph, but then it will be
Yeah.
then it will be a graphical guess that our data, our recorded data is still around 60. Okay, so what's the answer for third part? Why you should not go for
Like we can say 80 is outside of the range of the data to make the regression run, and then like you can say that. So extrapolation and should
yes,
not be done.
extrapolation means extending a graph. We used to extend the graph in O level also. He says that
Yeah, yeah.
if you want to go over
Hmm.
80, you have to extend the graph. If you extend the graph to 80, then there are no other crosses there. So the result would be not very accurate. Okay. So we are stopping here. We have completed this. Example. The chapter is not completed. We will inshallah continue in our next class. Allah Hafiz.
Yeah, okay. Allah Hafiz, sir.